Hello students, today in this lecture we will talk about the functions, okay, and here we will discuss some questions of quadratic by quadratic, how to find out the domain and range when we are given a function based on quadratic by quadratic. Then after that we will discuss about types of modulus function, the properties of modulus function, and then we will move to the trigonometric functions part. Okay, so let us start with the question that we have covered yesterday part, so that is quadratic by quadratic. So let's suppose if we are given the question like this, we need to find range of y equals to x square minus x plus 1 upon x square plus x plus 1. Okay, so here what we need to do is we will cross multiply this. This will become yx square plus yx plus y is equals to x square minus x plus 1. Okay, then we will take all the terms to the single side. Let's take all the terms here. The coefficient of x square, then it will become y minus 1. The coefficient of x will be y plus 1 and the constant term would be y minus 1. Now we get one quadratic equation in x square. Now if this equation to have real roots, we can say that this discriminant of this equation should be greater than equals to 0. Okay, now if I find out the discriminant of this equation to be greater than equals to 0, discriminant is nothing but b square minus 4ac, that should be greater than equals 0. So the value of b would be y plus 1, hence this would become y plus 1 square minus 4 times y minus 1 into y minus 1 square. Okay, now if we will solve this, it will become y plus 1 whole square minus 2 times y minus 1 whole square. Okay, because this is y minus 1 whole square and this is 4, so 2 times y minus 1 whole square, and hence this would become, we will apply the identity a square minus b square, that is equals to a minus b into a plus b, and hence we can further write this as y plus 1 minus 2 times y minus 1 into y plus 1 minus plus, here we have taken minus sign, so this would be plus 2 times y minus 1. This should be greater than equals 0. Okay, now let's utilize this space. Okay, so we have this quantity as minus y and minus 2 plus 1, so this is 3 minus y. So this is 3 minus y, and this would become 2y plus y, 3y, and this is minus 2, 3y minus 1. This would be 3y minus 1 greater than equals 0. Now how to check which region we will get? Now this expression will become equals to 0 at y equals to 3, and this would become equals to 0 at y equals to 1 by 3. Now let's check for the points. Let's consider any point here in this range, means beyond 3. So that would become, if we take any point 4, so 3 minus 4, that would be negative and this would be positive. So overall it would become negative. But we are looking for the region to be positive. That means this is not the region that we are looking for. This will be the region that we are looking for, and again less than 1 by 3 is not the region that we are looking for. Okay, hence we can say that the range of this function would be y belongs to 1 by 3 to 3, both closed. So in this manner we can find out the range of quadratic functions in numerator and denominator form, means in rational forms. Okay, so I hope now you're pretty clear about how to get the range of these type of questions. Okay, now let us move to what are modulus function. Okay, modulus functions. So talking about modulus function, y equals to mod of x, let's say, is the modulus function we have. So what is its definition in the region when x is positive and x is negative? Now let's talk about its definition. So if x is greater than equals to 0, this mod of x will open with the positive sign x. And when x will be less than 0, this will be negative x. Okay, now to plot the graph of y equals to modulus function x, now let's say if we have x-axis here, this is the y-axis, and in the region where x is greater than equals to 0, that means here in the first quadrant or in the fourth quadrant, but we have the line y equals to plus x. So y equals to plus x is the line passing through the origin and having slope equals to 1. Okay, and in the region when x is negative, that is x lesser than 0, y will be equals to minus x. Hence this will be the line y equals to minus x, and this is the line y equals to plus x. So this is the basic plot of y equals to mod of x. Now let us talk about if we have some another function, let's say y equals to mod of x minus 2. Okay, how to plot these type of graph? So let us see one general function, that is y equals to mod of x minus a, where a is any positive constant we are taking. Okay, so to plot this graph, we can say that now this graph will be shifted to the right hand side with a unit. So let's say this is x equals to a, and now the graph would become this. Okay, so this is the graph of y equals to plus x minus a, and this would be the graph of y equals to minus times x minus a. As you can see that at x equals to a, this would become equals to 0, and again at x equals to a, this line would become equals to 0, and at the point x equals to 0, this line would become y equals to a. That means this is the plot of y equals to mod of x minus a. Now we will talk about some properties based on modulus functions. Okay, let's talk about the properties based on modulus function is so talking about the properties of modulus function. Now let us say the first property is if we are given mod x greater than equals to a. So what is the values of x? So if mod x is greater than equals to a, I can say that x will be greater than equals a, or x will be less than equals to minus a. So both will be the cases possible when we are given mod x is greater than equals a. Now let us talk about the second property. Let's say if we are given mod x is equals to a, then we can open this with x equals to plus minus a quantity. Okay, this is the very basic property that we should take at the first point. Now the third one is when mod x is less than a. That means x will lie in the region minus a to a. Okay, so here x will be from minus a to plus a when mod x will be lesser than a. Or if you want to plot the regions, let's say when the case mod x is greater than a, this will be a. You can darken the region this side, and let's say this is minus a this side. Okay, and for this part, if we have mod x less than a, then this is a, this is minus of a, this will be the region minus a to a. X can lie in only in this region. Okay, so these are about some basic properties of modulus functions. Now let us talk about some questions based on modulus function properties. Okay, so let's say if we need to find out, question is find values of x for which mod 3x minus 2 is less than equal 5. Okay, so this question is given to us. Find the values of x for which mod 3x minus 2 is less than equals to 5. So how to solve these type of questions using modulus properties? So what we will say is we will use the property when we were given mod x was lesser than a. We will consider this quantity as x only. Okay, hence we can write this 3x minus 2 would lie in between minus 5 to 5. Okay, then adding plus 2 to all the sides, so that would become minus 5 plus 2, and this would become 3x, and that would be 5 plus 2. Hence 3x lying between minus 3 to 7. So let's divide the whole inequality with 3. So we will get here minus 1 to 7 by 3. So this is the values of x for which mod 3x minus 2 is lying or lesser than equals 5. Okay, now let us consider a very good question based on modulus properties. So in this question also we need to find out the values of x. So the question given to us is, let's say mod of mod x minus 1 minus 5 is greater than equals 2. Okay, so how to solve these questions? So if you face these type of questions in the exam, you will see that this is pretty simpler question using properties of modulus. So how to solve these type of questions? First we will equate this modulus, the outer modulus. So we will write this as either mod of x minus 1 minus 5 would be lesser than minus 2, or mod of x minus 1 minus 5 would be greater than 2. See, because we know that when mod x was greater than equals a, we know that x is greater than equals a or x is less than equals minus a. Yes, we are using this property of the modulus. So using the property, we have got mod of x minus 1 minus 5 should be either less than minus 2 or it should be greater than equals 2. Now we are getting this mod of x minus 1 minus 5. Let's take 5 to the right hand side. So we can write this as less than 3. And here we can write this as simultaneously mod of x minus 1 to be greater than equals 7. Now mod of x less than equals a, using this property mod of x less than equals a, that means x should lie between minus a to plus a. Okay, hence we can write this as x minus 1 should lie between minus 3 to plus 3. Hence we can write this as x lying between minus 2 to 4. So from here we are getting one region that x should lie between minus 2 to 4. Now let's solve this inequality. We have mod of x minus 1 greater than equals to 7. So in this we can write this as x minus 1 greater than equals 7 or x minus 1 lesser than equals minus 7 using the above said property. Okay, hence x should be greater than equals 8 from this part, and here we are getting x should be lesser than equals minus 6. That means now we are getting the regions. Okay, so the first region is minus infinity to minus 6. So x belongs to minus infinity to minus 6. Minus 6 would be in close bracket because we have equality also there. Union minus 2 to 4, minus 2 to 4, and union 8 to infinity. So student, these are simpler questions. Just you need to use these properties when you have inequalities under the modulus. Okay, so this was about the modulus function, its properties, and the questions based on modulus function. Now let us talk about some trigonometric functions. So talking about trigonometric functions, so the very first basic trigonometric function is y is equals to sine of x. Now let us plot the graph of y equals to sine of x. Okay. So this is y-axis and this is x-axis, and this is the point x equals to 0, this is x equals to pi, this is 2 pi, 3 pi, and this will be pi by 2, this will be 3 pi by 2, 5 pi by 2, and this is minus pi by 2, minus pi, minus 3 pi by 2, and minus 2 pi. Okay, so now talking about the domain of this function, as we already know what is domain, the values of the input for which the function is defined. As you can see that this function is defined throughout the domain, that means x can take any real value. That means the domain of this function, we can say that is equals to r, where r stands for all the real values. And talking about the range of this function, the range of this function would go from, this is minus 1 and this would be plus 1. So the range of this function would be minus 1 to 1, both in closed bracket, and the function can take values in between minus 1 to 1. So this is about the domain and range of this function y equals to sine x. Now let us talk about the period of this function. So talking about the definition of the period of a function is the interval after which the functions repeat itself is what we call as the period of the functions. Now that means if f of x becomes equals to f of x plus t, we can say that this t is equals to the period of the functions. Now for sine x, y equals to sine x, the period of the function is 2 pi. As you can see that the graph from 0 to 2 pi, this graph is shifted here, so this graph is repeating itself after every 2 pi interval. That means the period of this function is 2 pi. Okay, now if we are given that sine x is equals to 0, we need to find out the values of x at which sine x is equals to 0. That means these are the points. So we can say that here x should be equals to n pi, where n belongs to integer. So similarly, if we are given sin x is equals to 1, we can say that the values of this will be 4n plus 1 pi by 2. If we are given, I will also tell you how to check for these regions. Sin x is equals to 1, I can first write x is equals to 4n plus 1 times pi by 2. See, if you want to calculate this, how we will get these values. So first you can check sin x will be equals to 1 first at pi by 2, then it will be equals to 5 pi by 2, then the another value will be 9 pi by 2, and so on. So as you can see that these are the terms of AP, and you can find out the nth term of the AP, and you will get the nth term of the AP as 4n plus 1 pi by 2 for this. So that is about the basic trigonometric function y equals to sin x. Now let us talk about the second trigonometric function y equals to cos x. This is y-axis, this is x-axis. Now we are talking about y equals to cos x graph. So this graph goes from here so this should take value like this. This value is plus 1. This is at x equals to pi by 2. This is pi. This is 3 pi by 2, and this is 2 pi. This will be 0, minus pi by 2, minus pi, minus 3 pi by 2, and this will be the region minus 2 pi. Okay, so talking about the domain of this function, the domain is all the values of the input that the function can take, and talking about the domain in this case, we can say that all real values is the domain of the y equals to cos of x. Now talking about the range of the function, in range of the function we can see that again this function can take only values from minus 1 to plus 1. That means the range of this function is from minus 1 to plus 1. And talking about the period of the function, that will be equals to 2 pi. So this is the period of the function, means the graph of the function will repeat itself after every 2 pi interval. So students, here we have talked about in this lecture y equals to sin x trigonometric function, y equals to cos x, and the rest of the trigonometric function we will discuss in our next lecture. So I hope you have pretty liked my lecture. So kindly share the video and like the video as much as you can. Thank you.